Good day everyone. So today we're going to tackle about the lesson The 6 Principal Views of Orthographic Projection. Before we start, I would like to introduce ourselves. We are the group 4. My name is Leslie Jane Ercido and we have Shilupino and Fazil Lilis. So what is orthographic projection? So orthographic projection represents three-dimensional objects in two dimensions, and the object is the view in the parallel lines that are perpendicular to the drawing plan. Instead of a single three-dimensional view, it uses different two-dimensional views of the object in orthographic projection. Orthographic projection is a two-dimensional drawing of a three-dimensional part, and the ability to create an orthographic projection is an important part of engineers' ability to communicate a design idea. So in orthographic projection, it is a two-dimensional representation of a 3D object, as you can see in the figure. Moving on, orthographic projection represents different sides of an object: the top view, front view, and right side view. So in orthographic projection, it is a way of visualizing different views of an object from their different sides, such as top view, front view, and side view. For more objects that we draw orthographically, we only require the three basic views, called the standard views. So the standard views are the front view, top view, and right side view. So the 6 principal views are created by looking at the object straight on in the directions indicated. So the 6 principal views are the top view, front view, rear view, bottom view, right side view, and left side view. So why use orthographic projections? We use orthographic projections as part of the engineering process. They allow us to see the length, width, and height, and they provide the basis for communication. They allow engineers and other professionals to communicate specific details about a part, house, or product. So how do orthographic projection works? So orthographic projection works. In each view of an orthographic projection, it shows all the vertical and parallel lines and details associated with that object from that point of view. So try thinking of it as if you're putting something into a glass box. So how do we create the 6 principal views? By the glass box method.
The glass box method. In the glass box method, imagine the object has been placed inside of a glass cube. Then, the 6 sides of the cube represent the 6 views of the object in orthographic projections. The image of the object is projected on the sides of the box. In the glass box method, there are some things we should notice: the projection planes, the projectors, and how surface A and B are projected. However, if the box is unfolded, there's a possibility creating the 6 principal views of orthographic projections: the top view, right side view, rear view, left side view, and the bottom view. What are the difference between the right side and the left side views? Right side and the left side views, they are mirror image with one different line type. And what are the difference between the top and bottom and front and rear views? So these 4 views are mirror image with different line types. And which views have the least amount of hidden or dashed lines? So it must be the front and top views. And as far as I know, if the both sides of the object are symmetrical, so it means that you don't need to separate them into a right and left side view. And the next is the front and back view of the object is the same, so it basically the same as before. If they are the same view, there is no point in drawing the same view twice. Okay, it's not exactly the same view, but the drawing would be the same. And the bottom view, it doesn't matter for the product, or it is equal to the top of the object, either on a product on a final drawing. In view alignment, the top and front views are aligned vertically and share the same width dimension. The front and right side views are aligned horizontally and they share the same height dimension. So let's move forward and let's see another example of the orthographic projections.
This page shows the another example picture of a six principal view of orthographic projection. These are the six principal views. First is the top, second is the rear, third is the left, fourth is the front, fifth is the right, and the last is the bottom. The top and the bottom. When viewing the object from the top, what is seen is projected to a plane below the object. Viewing the object from the bottom, what is seen is projected to a plane above the object. Front and the rear view. When viewing the object from the front, the surfaces, the edges, and the intersections of the object seen from that point of view are projected to a plane behind the object. In the other words, the rear view or the back view always behind or at the front view. Left view. What is seen when viewing from the right side view is projected to the plane opposite the side view, which is the left side view. The right side view. Furthermore, the right side view of an object shows the depth and height dimensions, which is parallel to that left side view.
It's been a pleasure being with all of you today and taking the time to patiently listen to our discussion, the six principal views of orthographic projections. Thank you and God bless all.